Today we're looking at something really cool called AIDE, and it's an AI that thinks like a master Go player, but instead of playing on a board, its game is finding hidden secrets in huge piles of data. So let's dig in and see how it works.
You know, we're living in this age of just information overload, right? Companies, scientists, you name it, they're collecting these massive oceans of data every single day. But that creates a huge problem. How do you possibly sort through all of that noise to find the insights that actually matter?
And this problem is so common, it actually has a name: the data insight gap. So in this first part, let's break down what that really means and why it's such a massive headache for pretty much everyone.
To put it simply, there's this giant chasm between just having data and actually understanding it. I mean, turning raw numbers and spreadsheets into knowledge you can act on, well, that's incredibly difficult. It usually takes a whole team of experts and a ton of time.
The official term for this whole process is knowledge discovery. And what I love about this definition are the key words: non-trivial, implicit, previously unknown. We're not just talking about making a simple chart here. We're talking about hunting for those surprising, hidden patterns that nobody's ever seen before.
So how in the world do we start to automate this hunt for hidden treasure? Well, the answer comes from a place you might not expect at all: the world of high-level strategy games.
I'm sure you remember hearing about AI systems like AlphaGo that became unbeatable at incredibly complex games. All the secret sauce behind that success is an algorithm called Monte Carlo Tree Search, or MCTS for short. It's just brilliant at navigating these gigantic search spaces where there are bazillions of possibilities.
Okay, so MCTS basically works in this clever four-step loop. First is selection. It picks the move that looks most promising based on past games. Then, expansion. It tries a totally new, unexplored move just to see what's out there. After that, simulation. It rapidly plays out the rest of the game to see if that new move leads to a win. And finally, backpropagation. It takes that result, win or lose, and feeds that knowledge back to update its entire strategy. It's this beautiful balance between using what it knows and exploring the unknown that makes it so powerful.
And that brings us to AIDE. We're going to see how this system takes that powerful game-playing brain and points it squarely at the world of data. This is the big aha moment, the huge conceptual leap. What if you could reframe the entire messy process of data analysis as a game, a single-player game, where the goal isn't to beat someone, but to find the most interesting thing you can?
This slide just lays out the analogy perfectly. Your game board, that's your data set. The possible moves you can make, well, those are all the different ways you can slice, dice, and analyze the data. And a winning strategy? A checkmate? That's when you uncover a genuinely surprising, valuable insight. It's such a simple but totally powerful way to look at the problem. So, what does it actually look like when AIDE makes a move? In this section, we're going to peek under the hood and see what its gameplay looks like when it starts exploring a dataset.
AIDE basically has two kinds of moves in its playbook. First, you've got data actions. These are moves that change the data set itself, things like picking certain columns, filtering out rows, or grouping data in new ways. Then you have model actions. This is where AI applies classic data mining tools like looking for clusters or finding outliers to uncover patterns in whatever view of the data it's currently looking at. But how does AIDE know if it's winning, or even on the right track? It uses this metric called interestingness. You can think of it as a score, from 0 to 1, that rewards the AI for finding things that are, well, peculiar or statistically weird. Like if it finds a really strong connection between two things you'd never think were related, or a little group of outliers that no one's ever noticed before. A high score is like the game telling AIDE, hey, you're onto something good here. Keep digging.
Okay, this all sounds fantastic in theory, right? But does it actually work? Can a system like this really automate that incredible aha moment of genuine discovery? Let's take a look at the results. So, to put AIDE to the test, the researchers did something really smart. They didn't just give it some random new data. They used famous, public datasets where human analysts have already found important insights over the years. The big question was, could AIDE find those same insights all by itself with zero human help? And they really put it through its paces across a whole bunch of different fields. You've got biology, census data, chemistry, and really complex medical data on heart disease and diabetes. They wanted to see if this thing was a one-trick pony or if it could work anywhere.
And the results were pretty mind-blowing. For instance, when it was digging through the diabetes dataset, AIDE, on its own, found a really important and non-obvious pattern. Patients who were first admitted to the hospital through the emergency room were way less likely to be readmitted later on. I mean, that is exactly the kind of valuable, actionable insight that every organization is desperate to find.
So what AIDE really shows us is that by just reframing a hard problem, by turning data analysis into a game, we can unlock a whole new way for AI to help us. It just makes you wonder, doesn't it? If we can automate discovery in data, what other huge challenges in science or business or medicine are just waiting for us to turn them into a game for an AI to solve?